Okay, sorry about that, Lisa. So what I'm doing today, I already started class a little bit, and I'll review what I just did for the sake of everyone else here to get a short review. So I'm covering an example in Barry from pages 75 to 80. And what I'm doing here is I'm setting up my models, priors. So my example is that Aziz and I, we are both seekers in a game of Quidditch, and we assume that the prior probability of me beating Aziz is about 60%. What we can do here is we can set that up with a series of models, starting at 0, 0% chance of me beating Aziz to 100% chance of me beating Aziz. And we did that, by 10% increments. So you can see that. And then we did as a class, or as I dictated, we assigned prior probabilities to each of those models. Then we wrapped it into a data frame. And as you can see, here are each of the models. Here's like a 0% chance of me winning, 10% chance of me winning, 20% chance of me winning. And then we assign prior probabilities to each of those models. To get the mean distribution, you multiply the models by the priors and you sum them all together. So that's just where we have my 60% chance of me winning. And then when you're assigning priors, you have to make sure that it all equals 100% at the end of the day. What we did, I'll share this code with you as well, is that then we graphed the priors. So here's the priors. And then we drew a red line for the intercept right here. Now the next part is we're going to calculate the likelihood. Remember, the likelihood is the probability of your data given the models, right? So remember, what we observed then is that Aziz then beat me. I won once, and then Aziz beat me twice. So he got the snitch when I failed to get it. So what we can do here is we have to multiply all of that together. So your table models, right? So this is this is the likelihood of having one win for me. That's that likelihood is this right here. And then I'm going to multiply that by 1. This is the likelihood of 1 loss, right? So remember, this is I won. This is I lost. And then I lost again, right? All right, we'll expand this out. Cool. So remember, this is showing how weird your data is given that the model is true. So you're assuming and remember, this is actually applying, this is like a cheat right here. I'm doing the same thing to each one. So you take a look at this. Now let's look at table. There we go. So as you can see, here are my likelihoods. Now let me go, I guess I can break this down for you guys until I just do one at a time. So if you do 0.4 times 0.6 times 0.6, right, we get 0.144, and that's the same as this value. So this model assumes that Jake wins 4 out of 10 times, right? Then Jake won once. That's 0.4. Jake lost. That's 0.6, right? So it's 1 minus the model. And then Jake lost again. That's 0.6. When you put it all together, you then get the likelihood. Does that make sense? So let's assume a different model. Let's assume that Jake wins 8 out of 10 times. So given that Jake wins 8 out of 10 times, and then you observe that Jake wins, the likelihood of that happening is 0.8, right? And then Jake loses, that's 0.2. Then Jake loses again, that's 0.2. Do that, 0.03. So that's the probability of me winning once and losing twice. The likelihood of me winning once and losing twice, given that like my overall record, like the kind of underlying construct of how many times I can beat Aziz is 8 out of 10. Does that make sense?
Yeah, I'm not getting that third column in the table. Table now.
Okay, so make sure it's table models, and do 1 minus or okay, cool. Yeah, thanks, Aziz. Okay, so does that make sense, or any questions about that? Okay. All right, cool. And are you guys all caught up and stuff too? Do you guys need me to like pause anything? All right, sweet.
I have curiosity, like, what happens if you have way more than 3 pieces of evidence?
It gets more complicated. Yeah, it just keeps on going. Yeah, and this is why we don't do it this way ever. This is kind of like when you're learning ANOVA or regression. First, you do it by hand once, so you get the concept. Then you never do it by hand again.
So this is the equivalence of doing it by hand.
Yes, this is basically doing it by hand, but not with a calculator, but using R as your calculator. Yeah, that's exactly what we're trying to do here. Like, who even owns calculators anymore? Okay, cool. So we can plot the likelihood now.
So when we doing it by hand, that's just an example of 0.4 times 0.64.6. Usually you just use that code and it would do it on that.
Oh, I would never use this code. This is totally impractical. So the question is, like, would I ever do this on my own data? My own data never looks like this because I've artificially constrained the world to 11 possible models. There could be like hundreds of models, right? So this will never actually work. Only in a very weird example can this model work, and I'm just showing it to kind of illustrate a point. So I'm simplifying it to the point of it doesn't have real world application, but it shows the concepts in a way that's very easy to follow. And for those of you who are new to R, it also shows it, it kind of slows down R a good bit. I'm getting used to running it. Okay, so we can plot the likelihood right here. Sure, we're still, yay. So let's plot the likelihood. All right. The ggplot. Here. What does this data equals table mean? So ggplot is going to look for columns or variables. I'm telling it to look for it in the table data frame. And then so x equals models, y equals likelihood. Sweet. And then plus all right, cool. And then we can also do, I just put L here. So now we get the likelihood right here. And that's what looks like plotted. As you can see, it's kind of shifting me over to losing more too. That's the other part. Because I don't know, I'm just not as good as Aziz, even though I put myself as better in my priors. Okay. So the next step is to calculate the likelihood by the prior. So I'm just breaking, so the real goal next is calculate the posterior probability. I'm just breaking it up into 2 steps, as I'm doing here. So calculate the likelihood times the prior. I'll just call this LXP. Cool. Table LXP. Let's see, priors times table. So priors, what do I multiply the priors by? Likelihood. Yep, sweet. Okay. Run that. Run that. So these are just the likelihoods times the priors. You know, just this column, sorry, this column times this column. And remember, because we said that there's like a 0 probability of me,
Jay, can you show that line code?
yeah, yep. There you go. Thank you, Amanda. That's what your day should look like. So remember, initially we said that the priors were 0 for me never winning and for me always winning. So then the likelihood became 0 as well. And now the likelihood by priors is 0. Cool. Any questions about that so far? All crystal clear. Sweet. All right. So now we do the cool part. We calculate the posterior. That's the posterior right there. And then we do so we're going to divide every likelihood by prior table. We're going to divide that by here. What is the sum table? Cool. So the sum. So what is this really? This is just part over the whole. That's all it is. So we're dividing every likelihood by prior by this value. That's all we're doing. Now the posterior, yay. So these are our posterior probabilities for each of the models. This is what happens after 1 loss and the 2 wins. And then we get the mean of the histogram. I guess we can plot it too. Yeah, let's do that. So we'll make a graph of posterior. Right, cool.
You have 2 in GT.
I do. Thank you. Cool, then. Sweet, so there's my posterior probabilities now. So you can go that back, likelihood, and then priors. So priors, likelihood, posteriors. So although this is like an artificial example, you'll never actually have like models in the real world, and they're often a lot more complicated than just hits or misses. Understanding, but this is basically the application of Bayes' rule to a type of problem. You know, it's like a better application of it, and hopefully you can understand it a little bit better. And then if we want to get the mean of the posterior, it's very similar to that too. Okay, sum. Table. Then there is our new posterior. So now we'd say that there is just a 53% chance of me disease next, as opposed to our original value of a 60% chance. So there you go. So that's that. Hopefully, any questions about that or anything? All crystal clear.
What is the dollar sign function?
Yeah, so that calls out a column name. So you do data frame name, and then dollar sign column name. Let's spin out the whole thing. So for example, you have table. This prints out the whole data frame. If I do table LXP, that's only the column. That's only one column, this column right here. And do table models. Is it another way? Is if I sometimes like it's a pain to know the column, like the column name, because I do it by column number. So this is where you use the square brackets. Remember Pat talked about this a little bit. So what's on the left of this comma? Rows or columns? Rows. On the right, it's columns, right? Just do that. And then say I want column 1. I get column 1. If I want like columns 1 and 3, I can do that too. Different methods to call the same, to really do the same thing. If I only want rows 1, 3, and columns 1 and 3, I can do that. Yeah.
I'm not sure I understand conceptually what the column LXP was for.
That's just like a previous step, posterior.
Oh, so it's like
I just did 2 steps.
Okay.
Yeah. Because once you calculate them all, so what you do, you multiply the likelihood, the likelihood with, sorry, I'm just blanking out. The likelihood by the models. Priors, yeah, sorry. Likelihood by the priors. Yeah, so you multiply them together. And then you have to divide each of those values by their sum. to get part over the whole. If that makes sense. No? Okay.
Let me formulate my question better.
Okay. And then another thing you can do here too, so you can also name as well if you wanted to. You can name it models, right? And that works as well. So these are all different ways to kind of pull data from a data frame. All right, cool. All right, so now we're on to the super fun part, and that's using Stan. All right. All right, so this is where it can get a little more complicated, and this is where most R users can help you if you get stuck too. So that. And example 1. All right, so most of you guys know how to do a linear regression in R, right? Who here does not know how to do linear regression in R? That's fine too. So the first step is that you guys are going to have to load the foreign package. You can use the foreign package in R to download data sets that R doesn't read by itself. So it could be SPSS, it could be SAS, it could be almost any type of data set. So we're going to load the foreign package. Yep. Does that work for you guys? Head nods, head shakes. All right, cool. Cool. And then we're going to read the data in. So you will need to have your data in the same working directory you do now. So did you guys make out your own separate project directory for this stuff? Did you guys end up doing that at the beginning? So make sure right now that you drag and drop the data into that project directory. So, or just copy paste it too. If you didn't, make a new directory. So go to session, set working directory, choose directory, and then put it to wherever it was. So it was probably like in your downloads, right? So where is that? So you can go to downloads, and you can make that your working directory. It's just a quick hack, and that's fine. All right, cool. So we'll call this data set earnings. And then this is a weird, it's read.bta because Gelman has like this weird, it's like Strata or something. I forget what it's called. So now I have to tell R where to find the data. Because remember, so this, make sure this is unzipped too, that you unzipped that file as well. This won't work with zipped.
Is RStan a package or something?
RStan.
You said to make sure it had RStan, and I didn't do that ahead.
Yeah.
Package?
It's a package as well, yeah. So make sure you have the package download. And then for it to work, you're gonna have to have Xcode installed too, if you're on a Mac. Cool, and we can go slow too for this. There we go. So this is the folder where all the data is, and then it's kind of like buried in the folder, so I'm telling it where to go. This is another folder called earnings, and then here's the actual data. Sweet. So just go write that out. And if it doesn't work, that's okay. Just let me know or wave down R user.
It doesn't like the read.dta.
Then load the foreign package.
Oh, yeah.
Yeah, you have to load that first. All right, cool.
Is this something you have to do every time? Load the foreign package. You have to do it each time for each session you're working in.
Yeah, you can. People can. You can edit your R boot up sequence to automatically upload some packages. Or if you saved your R workspace, it'll remember that too. But yeah, it's usually I always do it, and sometimes you have what's called masking. So if you have two R packages have a function called like regression in them, right? The one you load later will overwrite the earlier one. So that's the thing to keep in mind. When they have the same names for stuff, they overwrite each other. And then it's also easier if someone else is reading your code. If they can see that you uploaded that package, they can run it on their machines too. Cool. All right, are we all good? Does everyone have this downloaded? Come on, guys. All right, cool. So that looks good. Okay. So I'm going to show you guys how to do a regular regression in R. It's very simple. So you can do, we're going to call the model earn. This is the output. You can call your SPSS output. You can save it as an object. And we're going to use the LM function. Now our Y variable comes first. So in the data frame, it's called earn. So we can go look at that too. Oh, that's too big. That's what she said. All right, cool. So we can actually look at this. So you see, here are our values. We have earnings, height. So the earn is my dependent variable and Y variable, and then I guess I'm going to use height as my dependent variable, as my independent variable. Yep.
Out of curiosity, there's height 1 and height 2. Are you rounding to feet?
Oh, I have no idea what this data set actually means.
It looks like it's like 5'3", 5'5", like the feet and then the inches.
Oh yeah. Then I think it converts all the inches in height.
Maybe just plain height because it says
Yep.
in inches.
Yeah, we'll just use that plain height.
There's so many different things.
Yep. Now this won't work by itself. Why is that? Pardon me? Not quite. Why won't the R code work? That's really close. I just did tell it where to find the data, where to find the columns. Yeah. So data equals earnings. And
so you're calling it earn, but I get the column is also named earn, but they won't overwrite.
no, because the column earn is in the data frame earnings. So they won't overwrite. Cool. All right, now let's see here. And then you do summary. Earn. And yeah, here's all of the regular R output. Isn't that cool, guys? So this tells us our residuals, what values they are. And here are our estimates. So this is our intercept, and this is our B parameter for height. Standard error, t-values, and p-values. And then there's also R squared and adjusted R squared, which are usually pretty close together. So Yeah, this is pretty simple. This is like base R, very easy to run a regression with. Okay, so now we get to the fun part of using Stan. So what we should do first is create like a new script. You can just tell it R script, and it'll be fine. Then save it. And then we'll just call this, we want to call this, guys. We're making a Stan script now.
Stan example.
I will call it ex.stan. It has to end in .stan, and it's sweet because the new RStudio, it'll do code highlighting properly for Stan code. That's of a nerd, but who cares?
Sorry, I missed part of that. We're creating a new project.
No, not a new project.
Just a new script.
A new R script. Keep it in the same working directory you're already in, right? And then just call it anything, but it has to end. Oh, shit, named it wrong. Let's see here. I did this wrong. I said new R script. I should have said new text file. So we can just do that. Create new text file, save it, ex.stan. There we go. So now it knows. See that little icon changes? You can't really see, but obviously you guys can see that it there should be a change here. Whereas like it says R for those who say like little Stan symbol.
What did we call it?
Pardon me?
What did we call it?
ex.stan. Lowercase is fine. Yep. All right, so let's start specifying our Stan model. I'm not as familiar with this, so I might not be able to answer all of your questions, but I'll do the best that I can. All right, cool. So we can specify our data first. Brackets. There we go. So now we have to tell our it's going to come into it. So we can tell it this could be an integer. I don't know what this lower thing means. It means maybe it might mean that the lowest possible value is 0. And this is n. This is our sample size. So this is telling Stan how to take a value for our sample size. And then now I'm going to tell it each of the variables I'm going to give it. Here's vector. And this is earn.
Is this like vector the length n?
Yeah, I believe so. And then you have to like specify it first. Yeah. Now I'm going to our parameters. All right, vector 2. So we have 2 like beta values. Our intercept this is 2 because we have an intercept and a slope. We do, and then specify another value. And this means it can't go lower than 0. And then this is sigma. This is the standard deviation of, I believe, of our residuals or our variance that we don't explain the model. We only have 3 parameters. We have 2 beta, the intercept, the intercept, the B coefficient, and then we have like this error variance parameter or sigma. Cool, makes sense, guys? All right. And then we can specify the model. Oh, come on. Is earnings, earn, normal, oh, wait, sorry, I'm sorry. Oh, I did it right. Okay, cool. All right. And I believe this is where in the model portions we can specify priors and stuff. But here, I'm not sure exactly. You can this is where you can specify like your priors and like the basic how things are related here. So now we can save this. And now you could write this stand code within R if you really wanted to, and just surround it all in quotes and convert into a model. But the downside is you don't get the syntax highlighting like you do here. And most of the time, the examples they do put the stand code in a different file. They can edit.
So the normal turn colors here.
Yeah.
And didn't. Is that a bad thing?
Probably. Probably.
What's the color of
A lot of the times vector didn't turn.
Pardon me?
Like a lot of the times vector.
Oh, maybe it's just like
my
your color
Yeah.
highlighting. Yeah.
probably like yellow.
Yeah. Okay, cool. So now make sure you save that. That's it for the model. This is like a pretty simple model. And let me also, I should have said this earlier, but the goal doing this is to show you guys how to use stand, but relative thing is something some of you already know, and that's R. So for those of you who know R, this should be a little bit easier. For those of you who don't, at least you kind of compare them. And you already know frequentist models at the very least. So this gives you kind of like a ground truth when you're doing stand to compare against. And then you can then write your own stand code for more novel types of problems.
Can you comment in the stand code?
Yeah, it's like double. Just use that. Yeah. Yeah, just do double. Is it? I always get confused. Is it forward slash? Is that backslash?
I think this is backslash.
Okay, yeah, backslash. Yeah, just double backslash.
I don't think it's-
Oh,
I mean, it still worked with the hash,
with
the comment in the stand code.
the hash works still. Okay, cool. What's it called?
Octothorpe.
Octothorpe. All right, Nick. Yes, that's all right. I'm nerdy, but not quite that. I'm just kidding.
It's called
Hashtag. Cool. All right, so what we can do now is we can read the data. Let's see here. So we'll just call this, I don't know, so we can read our model code in. Let's call it Stanford. Makes sense, right?
Stanford.
Yeah.
Okay.
All right, so we're just gonna use some like read character. Then make sure you put it in quotes and write the name. So ex.stan. File.info. There might be a more elegant way to do this. Basically, what this line of code does is that it just reads in it just reads in a text file and just has it all like one block of text. And for whatever reason, you have to tell it how big the text file is. So this tells it how big the text file is. It's just kind of silly. Let's see here. Sweet. Does that work, everyone? I know that there's some special library. All right, cool. All right, cool. Some head nods. Sweet. All right, what does this look like? So if we want to print that out, this is just all of our code. That's all it is. Nothing very special. All right, cool. All right, so now one of the real pain points for Stan is that you have to restructure all of your code, all so your data frame. So, regular R can just read in, it knows this data frame, it knows how to make it work. For Stan, you have to specify everything. You have to like tell it how large sample, like how and tell like where to look. So we're gonna restructure our data. Sweet. All right, so it's called like dat2. Yeah, we'll call it dat2. Am I in the right one? Good. All this, we'll make a list. N equals. So what does this do? This tells us that our sample size is the same as the number of rows in the earnings data frame. So this is the number of rows we have in the earnings data frame. Make sure you have a comma here. Go earn. So remember, this is going to be like what we have in our Stan code. So we know how we have, see how we have earn and height. So we have to tell it which values are earn and height.
Is it earn equals earn?
Earnings. It's pretty bad. Yeah, this is earn. And then,
And the same thing with height.
yep. There we go. Oh, nice. Call me out my errors too. All right, cool. So now we have, and this is like a list. So the list is like the most flexible type of object you have in R. So you can have characters in there. You can have data frame. You actually have like a list of data frames. So it's like a very flexible type of container where you're storing the information right now. All right, cool. Okay, so we're gonna call this, I don't know, ResStan, or I need better names. I don't know. We'll call it pig, all lowercase though. So this is gonna be, so now we're gonna run, oh, we also have to run this. Oh, come on. It's just freaking out.
Is it angry?
Yeah, it's really angry.
It's angry. Is that what I heard called like the spinning thing of death?
Yeah.
Okay.
I might have to kill R. It's freaking out. Oh, it stopped. Sweet. Okay, so now I'm going to run our stand code. So we have pig here. That's just the name of our stand model. Oh yeah, forgot library R stand. All right, does that work for everyone? You're okay, Morgan? Is it running on your piece of paper?
On my piece of paper, it's running great.
Okay, cool.
There's not being a team player. So.
Oh, that's okay.
Scan headers cannot be found.
Yeah. Could you install stand headers? All right, Kevin, do you have this working? All right, cool. All right, Amanda, you good too?
Yes, I think I need to update on it.
Okay. All right, cool. Anyone else need more time? So no, did you get to work? All right, sweet. All right, let's go run this. So now we're gonna use the stand function, model code. So now we need to use Stanford. Now we use data equals dat2. Chains, I'll explain this just a second, equals 3. Iter equals 3000. And then warm up 500 and then, oh no, 10. Okay, so I really don't understand these very well, but I can give you like a very high level overview. So I like to think of iterations. That's kind of like going to the gym to work out, right? You do treadmill, you do weights, that type of stuff, right? Chains, that's like the number of times in a week that you go to the gym. So this tells you how many times you repeat the iterations. Warm up, it's kind of going to the gym to warm up. What stand does is it'll like throw out the first 500 iterations because it says that they're warm up. The idea is that it takes sometimes it takes a while for it to figure out where your parameters are. And it'll go like way haywire early on, then it kind of like settles into a groove and figures it out. And then I don't know what thinning is. So oh yeah, totally blue balled you there, sorry. Yeah. And then when I don't know, you can also go like this. Ah, no. You can like read this stuff. Yeah. Oh, yeah. I know it's a positive integer specifying. Sorry, Aziz.
Oh, that's funny.
But not that sorry, though.
Are you sorry that you're not sorry?
No, I'm not sorry about that either.
Oh.
There's no matter, sorry.
All right, cool. So now we can go run that code.
No, I just thought he was. It's weird.
Error.
You did? Let's say.
It says it was expecting a colon.
Oh,
I think that's in my SAM code.
yeah, go back and add semicolons.
Yeah. Can you leave it on where you are?
Yeah, yeah.
Oh.
The colons are moving to another line in a text file.
Yeah, but I forgot the very last one.
After,
Let's see here.
Error in the font.
So it's not like the NAs. So, so I forgot to write this in. Not how you handle missing data with your own data. The theme of missing data is that it sucks, and it just sucks in different ways. But it's always bad. And it's interesting. You can read a little bit on Andrew Gelman's blog that the missing data is part of the reason why his polling estimates were so far off. So you can read more about that because you have a lot of non-respondents in the polls, but if they're correlated with liking either candidate, you're screwed. So because he didn't account for that in his models, which made him more overly confident in his prediction that Hillary would win the election, way overconfident. So, all right, so just one sec. I need to find that code.
How long did it take you to run the code?
What do you mean? It only takes like a minute or two. But it shouldn't work because sorry, I need to look at this.
Okay, so all the errors are actually correct right now.
Yeah, this should not work right now. So we can just go remove the missing data.
Yeah, I totally understand.
yeah, I don't see.
That's is not an NA, specifically in columns.
Yeah, it's all the NAs are in earn in that column. So what this line of code does is that it finds what this does is it finds everything that is NA, right? Then this is telling you I don't want anything that is NA, and then this is telling you to apply it to the rows in the data frame. So for every time, so if I removed this exclamation point, it would only be NAs in that column. So make sure you write this line of code. It won't work otherwise.
Which one is dot NA? Bracket, the other one is dot NA. The screen. So little on the screen.
What is?
Like, even being this big is still hard to see.
Oh, sorry, see? Oh, I could say something.
I'm not sure you can do much because then it would be like the code would be so small. It wasn't a complaint, it was just. No, the experience knows.
Let's see how this works. That was a little too big.
Yeah, that's what.
What do you got-
I probably can't do anything about it.
Do you guys want to? Let's see if I can specify. No. Sorry, guys. It's okay. It was worth a try. All right, so this won't work either. Now, because I need to rerun this. So make sure you rerun all this stuff.
Everything
From DAT too. Yeah, after, make sure you run your, run this line and then run this.
I got a stupid long output of, I'm pretty sure, for all warnings.
Yeah, you should get looped through chains and stuff. So I'm already on chain 3.
Can I see the pig code again?
Yeah.
Yeah, I get a bunch of errors.
You did too?
Yeah.
Shows
I
like
think
434 lines
actual
and then
standard
error
code.
code.
Oh. What does it say?
It's a paragraph of errors.
It really is.
Error
Yeah,
in
you have to
compile
scroll.
code,
Yeah.
F
To see
comma
it all.
code. Yeah. It's long. Compilation error function.
I'm pretty sure it's my stand code. Do you mind pulling that back up though?
Yeah, yeah.
So,
Are you Mac users? Okay. You're good.
It might be a difference between Mac and PC.
Yeah, there might be some weird. Aziz, do you have it? Nick?
It's not working for me, but I'm getting a different error.
What does it say?
Variable does not exist.
Oh.
Processing stage equals data.
So are you sure these are all correct? All right.
Let me run everything again.
does yours say like in addition error messages 1, 2, 3?
Yeah.
If I have? No.
No,
So you go back to the stand. When did you
Yeah.
download your R?
What works?
I think my R is out of date.
could that be it?
I just downloaded it at the beginning of the semester. Oh, it updates.
Does
all
it
the
work?
time.
No. All right.
All of them. I'm gonna just try and check roughly.
I just
I'm gonna check
updated
this
the
out.
newest version, and it's called Sincere Pumpkin Patch. That's what the newest version.
All right, so we can check real
You
fast.
just download, go to R command,
In here, install?
yeah, uninstall the old R, reinstall the new R, and then R Studio fills in the gaps. So the names for the spin wheel. Sincere Pumpkin Patch. I like this one. The last one was called, we got plug in your hair. Bug BH.
You
You
just-
wheel spinning there. I like that. That's what it sounds like.
Yeah, that's one that I have bugging in there.
Yeah, the newest version is sincere.
Sincere.
Just R cran in, just type in R cran. Find it.
I'm ready.
Yeah.
Yeah, I'm warned about my R is just out of date.
Great.
Ooh, I went to 11. Yes, I did.
Do this. Download 332.
You're nothing.
This one?
That's it.
Make sure you save all your
Throw it down.
Good call.
I think you can also run. So if you guys go, this is kind of a pain to find, but I can send out an email. You can run, No. All right, this is the same for each. So the way to check if your stand code's working, so you can.
Is that the thing where it's going to say it has to equal 10?
Pardon me?
Is that the piece of code that, like, when you're downloading it, it says it has to equal 10?
Right. So. So make sure that this code works. That's the first step, because if that doesn't work, it means that there's something wrong with the way Stand's installed on your device. So I just sent it out to everyone.
Okay, thanks.
Yeah.
I mean, I always do this.
Just make sure you're not currently running.
So those of you who are in problems, does that work? Do you try putting that, copy and paste it in?
I'm in the process of updating my R&R studio.
Okay. Yeah. All right. Do you guys want me to go forward with this? I think I'll just go do that. And then at least you can write it down, then you can figure out what's going wrong, maybe. Sorry. Yeah, I had problems with Stan running too. I had to enable Xcode on my Mac. That was a weird thing. All right. What we can do. We have enough time.
You're gonna
Actually,
send out this code, by the way.
Probably. Oh yeah. This all goes out. Yeah. Actually, do you guys want to take a break for a little bit?
Yes.
Let's do that. All right. Cool. 10-minute break. Whatever.
There might be enough time for that. Maybe.
I just got that. Like, track 1 is supposed to be doing more correlation right now. Track 2 is working on a preliminary study that.
I got the same error when I tried to run.
Oh, yeah. Yeah, I was dating.
And then
Well, she sent it to a. You start seeing what they're doing is they're having to through a. Login portal, and they're monitoring.
Anyway.
It's not exactly the same state as trying to code, but I understand. I came out like same time, the automation, and I was, more or less kind of pulled them out of that.
I didn't have to down those entire separately, I just had to load it afterwards, right? In case they're friends.
I looked at my the automated stuff. So from track one stuff, the automated I was like last. Yeah.
And then, yeah.
I mean, it's a way of getting. I mean, more people are signing up than I have time for. Yeah, I mean, it just started like 2 days ago.
So for me,
My students still, well, now probably down to 12,
when I,
only 800 hours.
Yeah.
loaded.
A couple days ago, my students were 1,000 hours. Your students. Well, oh, my class.
It was just this.
So they owe me 1,000 somehow. So I was like, so you benefit from my
And then it
Oh,
turned
yeah,
into
so it was
that
bad
too.
for a long time.
I'm sorry,
So it was great.
so restricted the data, that too should have like that.
Hold on to your seats, put your time on.
Because I feel like so Greg's related to the university is based off of that he's got data in the past probably 1.5 to 2 years. It's just been
Oh, you
fairly
can run.
slow compared to what it's been in the past.
Yeah.
What we've had in the past is all these about 10 some slots filled.
So you know,
And people are getting it's about 120, 130 per semester, and our RAs are getting like 60 to 80. So he is saying the data that he would expect. And I wonder if this temptation is going to break apart the model as just
oh, yeah, yes, yes, yes. But I mean, in terms of comparison, where, oh, I can specify whatever. You can just see.
Yeah, it's very
Okay.
it's very
So right now, it's like just like on.
It's gonna be crazy, but then our other problem now, I struggle to quality of our data because if there's fundamental difficulty, these people.
Oh, sorry, and then you talk about that? Yeah, talk about
So, yeah, I know, yeah. There's not one that's basically different population.
At the same errors. Pretty solid, good perception. This is what I get.
Yeah.
That's what makes it.
I mean, my.
Is it,
it's also about what is why I have no idea.
You know what?
But you copy that? It didn't. It's the one I can say. So if you go down the hallway, there's like the first and second door. Yeah, it's definitely installation.
So it's like, I was gonna like, do some like verbal speaking.
You said,
I just
what?
want to
Three,
I have some notes.
just,
Damn it, I was
very
ready.
busy.
We saved the first one, and I'm like,
I was
the
gonna say-
light.
You know, like his,
Actually, right, on the advanced control displays, we got some really small.
That's big ass ass.
Like supervisor.
he came back from that.
And the bridges that are already supposed to be expensive, and I got the people for his study, which actually we install expires in 30 days, and it was before it expires. So we'll just do that. So we got 60 days of this last month, and I'll probably
Seems like a lot of
Yeah.
Could it be a PC thing?
Pardon me?
Could it be a PC thing?
Yeah, did you install all the dev tools beforehand
Trying to
too?
get-
I don't want that development tools on the website.
links you sent us?
Yeah.
It's all over.
Yeah, no, there's the, so we just go like install sand windows. Just go to just Google that.
So I think my it was like,
No.
that's fine, nothing really goes on much. Yesterday, I was like, obviously in a terrible mood. So I had to talk about sexual coercion. I can't do too much.
Yeah, no, there's like a whole, on the stand website, you download 2 packages, 2 programs.
You're out of town. These are down to your response.
Yeah,
It's like
so
whatever.
you change configurations. Yeah, that's what you do.
That's 2 times the.
Download all these.
One out of town.
Yeah.
Last time we were wedding before that was. You think it just.
You see that cut? You need to change.
Wait, no, wedding.
Yeah.
So that you were out and started doing something else.
Do I need this part to go on the project?
No, he told me about it. You met like, they talked about the rhythm.
What else do I need on this next tool chain?
Whatever is on.
Yeah.
Go install the.
Oh, okay,
But yeah, no, I'm really farm things to talk about. Actually, one of them, I guess that was one of her.
Yeah.
And it was the other, I was like, I can't go to. Because if I do, it'll cost money.
Oh, the mark.
Yeah, did you hear that, Patrick? Just make sure that things are stand for work.
Oh, okay. Well, then that's not.
So you're good, right? Okay, cool. Yeah.
Yeah, the newest version of art. Go here and then scroll all the way through.
It's like,
It means that it's categorical variable.
The top.
at Freddy's or.
That makes sense. Like it's like,
It's a hard.
it's not linear. It's like
Is it console?
are continuous.
You're this person that goes in and you get the
Traditional dependent variables or independent variables, right? They're continuous. Yeah, and this is
Yeah,
like a
you're
factor
sure
that are like
really weird, they like really specialize in you, and you turn a corner and it's just like start sitting there, and don't do anything. I want to get ever, you know, get connected, like, but it's just like a really
dichotomous theory. Like, I mean, like they got really funny. Is anything try or more? So it could be categories.
Equals are.
Or you may have to say wrong. Yeah, only non categories.
Yeah.
There's like one that's like, I think it's like.
What's in your head? Or bugging you?
Yeah, man, this is huge.
But it's telling me I can't have our two.
Neither John nor Todd will be
Then I have to have an older one. I know she lives.
I'm not sure why it's telling me that because I have the same version.
Oh, no,
I only think about it and just like.
No, that is all.
Yeah. They did.
You might need to uninstall it.
I'll go back and look.
Did you go and download the rest of the stuff?
They don't say this at all.
Yeah.
It's like freaking.
It doesn't have to start.
But it's like,
Uninstall.
just like last night, I found out like if you went to Facebook, there's like a place you upload, but they just want you to upload like a Word document. It just literally says.
Okay. So now uninstall or
Oh, no. Yeah, so go to the email that gets sent.
These are professional universities.
That was good.
No, not that. You can leave.
Oh, I have to go to like contact the students now. It's not-
We're talking about the email that he sent a couple of days.
Yeah, it's not like.
It's a draw. You're a 20 minutes or 5 minutes.
We're just open up a window and Google search Spanish or BBC.
Oh, it's gonna be- it's weird though.
No. You can just, yeah, you can just Google.
That's like goes half sweet into like.
Yeah.
51 degrees.
Maybe you understand. So,
It's white bucks, yeah. British
because you have already.
So it's like always in like the 60s or 70s?
It's 51 degrees. It's gonna be like the low. The high and the low are very close. High 55, low 49. But that's still too cold.
All right, guys, I'm gonna get sorry. I know a lot of Windows don't have it working yet. I have a Mac, so I kind of figured out how to use it for Mac, but then I never figured out how to use it on Windows. So my bad there. But I'm gonna go ahead and, at the very least, I'll send out my R scripts and my stand scripts for you guys. That way you can have it yourselves. And I guess we'll use the rest of the time to compare the stand output to the regular regression output, and then work through one more example if we have the time. So cool. All right, are there any questions so far about not related to computer issues? All right. Okay, so next we are going to go look at the trace plot. So you see these a lot. Do it on pig. And then parse sensor parameters. We want our beta parameters. And we also want our sigma parameter. And then I think this is like when we don't want our warm-up values. Oh, we do want our warm-up values. You can see this is like the result of the random walk here. And this is why we don't include warm-up values, because they're kind of way off. And eventually it stabilizes and you have like a better estimate. So this is how like the random walk is drawing possible values from your posterior distribution, I believe. So that's relevant. Good to know how to do that. You'll see that a lot in on the web. Okay, cool. I'm going to see the output from our file. This is our Bayesian output. We can do print pig parameters or parse. We want the beta, and we want sigma. Sweet. Move that. And there we go.
Beta 1 is the intercept, and
Beta 2 is the yeah, right. And what we can do to compare that is the frequentist output. Let's see here. Let's see. So I could show it that way. Here. You guys have this installed, I don't know. It just makes it easier to compare. If you don't have it, just install it. Table 1. So go install table 1. Share vec table. Then what do we call our output up here? Earn. Yep. So take a look at this. So you can see how our height, it pretty much matches the Bayesian estimate too, right? And then you can see our intercept pretty much matches the Bayesian estimate as well. So you can see that there, that's intercept parameter, intercept B parameter. And you can also look at the confidence intervals too. So there's like there's 95%. Yeah. So cool. And then if you want to check the sigma value, you can do summary, earn, and then go here and do sigma. So that's our sigma value there, and you see it matches our Bayesian value as well. Pretty close. So cool. So that's how we can compare the outcome of our model to the Bayesian model. Neat. So that was just a very simple regression with one predictor and one outcome value. That's enough coughing, Jose. All right, cool. So now they can do two predictors. All right, what was the example for this? So probably the easiest way to do this would be to use the same data set. So we'll just call this earn2. Run another regression, LM. Now, on earnings predicted by height, and education, or ED. Yep. Data equals earnings. So that's pretty straightforward. Now, if I want to do the same model from a Bayesian, if you want to go see the output, you can do that too. Summary, earn 2. There we go. That's our intercept, B1, B2. Okay. So now, to this from a Bayesian standpoint, we'll have to go make another Bayesian script. So new empty text file, hit, we'll save this, we'll call this ex2.stan. Cool. Now we'll start writing it up our code. So data, it's there. So now we can do, we have to specify our sample size. By all the values we're going to input. Right, so there's our data. I'll make this larger. Cool. Parameters. Now this is vector 3 because we're asking for 3 parameters this time. Remember in the last set we only had 2 because it's just an intercept and a slope. It's now 3 because we have an intercept and 2 slopes. Then cool. Model here. And plus data 2 times height plus data 3 by education, comma, sigma. Cool. So you can see we have our intercept, we have our slope for height, we have our slope for education, then we have our error variance or error standard deviation. Make sure you save this too. It won't work once you hit save. All right, cool. So now going back, we're going to want to go read in the data, right? Cool. So that's all of the. So we need to read the stand code in. Now, change our data. So do dat2 to list n equals n row. Oops, sorry. Let's see here. This is like a very similar. I'm gonna do dat3 instead. Yeah, I missed a lot of commas. Thanks, Aziz. There we go. I'll run the model. Pig. So do stan. Auto code equals status. Data equals dat3. So change equals 3. Iterations equals 3000. Warm up equals 500. And thin equals 10. Let's see here. What's the ending here? Forgot a semicolon in my stand code, I think. Let's see.
Yeah, that should do it.
For some reason, I don't know if this is. For my code, it doesn't indent on the next line. Is that a problem?
These are called .stan. Is that new? Okay, I don't know. It could be that it's the older version of our studio. It's probably not a big deal though. Let's see.
We need to update the status with the new code.
Oh, you're right. That's it. Thank you. Yeah, so make sure you run this line again after you correct the semicolon issue. And there we go.
Where'd you change the semicolon?
Go to here, add it to here. Yeah. Sorry, guys.
So what about visualization? What's the norm in visualizing Bayesian regression?
Visualizing the what part?
Analysis. So is it just plotting out a regular slope?
Yeah, I think a lot of people. I really don't know. I know it's very common to report these charts, the trace plots over here.
Okay.
That's pretty common. Yeah.
I guess.
And I really don't know if there is a norm yet either, because it's still pretty new. Well, it's not really new, but it's new to social science.
I guess my problem with trace plot is
Yeah.
not sure what they mean.
If you look at the values, you can see kind of where like the mean of these things are about, it's like about like the mean, but the value they report and the output. So you can see like they have, we'll wait for it to finish loading.
Yeah, I'll show you.
Okay, so yeah, remember sigma? That was like around, what was it, 18? It was around 18,000. And you can see that's where this value is. It's around 18,000.
Okay.
And you can see, like, I think the slope of the second predict of the model is probably around 1,600. You can see that's where this is. So this is kind of like where we're sampling the values from. All right, cool. So we have that now.
Why do we care that whether there's whether we're plotting out the first chain, the second, or the first?
We're plotting out all of the. I think it does the whole thing. I could be wrong though. I don't know which chain it is, and it's also recording the warm-up values too. That's why it's wonky in the beginning. And then a lot of the times this stuff will go awry and it will get like way off. Like it's not your model. That your has no idea. Like I guess the MC function has no idea where your parameters are, so it's like all over the place. That means things gone wrong. I don't think you're alone. Yeah, cool. All right, so we can do a quick little comparison, then I'll let you guys out of here. All right. So we can see the Bayesian output here. Put the standbod. So here are parameters. This are intercept, slope 1, slope 2, and this is sigma. And compare the frequentist model. Table 1. To compare it this way, as you can see, our intercept is about the same, right? And then it looks like, just kind of ballparking it, very similar. The height value, yep. You can see the beta 2. So that looks pretty good. And then we can also look at the let's see here. Then there's the sigma value. You can see, here's the sigma. Yeah, it's like in the right ballpark. So that's what I usually have to do when I'm learning a new tool, is to kind of go calibrate something I already know and I'm familiar with. All right then, and then if you look at the trace plot as well. It doesn't matter if you use double quotes or single quotes. Yeah, that is true. Cool, and then you have your trace plots now. And you kind of see, like, so for example, beta 2 is about 1500, right? As you can see here, so you can see this is like where the trace plots are going. And it's like kind of, it's a little below 1500 right there. And you can see this is why we don't use our warm-ups, because of these weird tails. They would throw off our estimates. That's why in our clean data, we knock them out of there. So cool. All right, so that's all I want to give you guys. So I know I kind of went around. At least I'm hoping that the first half was helpful for those people who are learning R and who are maybe still confused about what's going on, with the to your likelihood and to your posterior. And then for the second half, I'm hoping that those of you who know R a little bit better were able to benefit and able to see how you can learn to compare what linear models in R to linear models in Stan. And eventually you can write your own Stan code that's like wildly different, answering questions that frequentist models cannot answer. As well, on that first link I sent out to you guys yesterday, he has, with the same data set we use today, the Stan team has gone through many more examples, for example, interactions in regression, multi-level models, logistic regressions. There's like a whole slew. If you can, like anything you can do in regression, you should do it in R and then in Stan on that website. And with this code as your template, you can do it yourselves. So cool. All right, thanks guys for coming, and have a great rest of your weekend and day. Cool.